Solve the following differential equation. So we got dy over dx, that means y is the dependent variable and x is independent variable. Solving means we are trying to figure out what is the function y. We need to find y in terms of x. Okay, so y here and derivative here. So we know that when we have y and some function, let's say px, a function of independent variable, the x is independent variable, plus its derivative dy over dx, and some function of independent variable as well, but we can divide through by that. So here is x, which is a function of independent variable, and equals some function of x again. Okay, that the function of independent variable, when we have in this form, this is called linear differential equation. And to solve, we find integrating factor, which is e raised to integral of px. Yeah, there's a negative sign, then you need to be careful. You need to take that into account as well. So you have this integrating factor, and you multiply both sides by the integrating factor, and we'll have the left hand side is derivative of dependent variable times integrating factor. So let's put this in this form. So all we have to do is divide by x. Okay, we just want to leave dy over dx, divide by x, and x is positive, so it's possible. We are dividing by x, so divide by x, so negative, let me write in this way, 1 over x y. This y is there, and 1 over x, and we are dividing by x, so one copy of x cancel, x sine x. Now this one is in this form. So to find the integral, let me write this one is a star, and I am just referring this differential equation as a star, and let's say this is linear differential equation. Okay, and here px, this p, okay, that is negative. Okay, you have to take that into account, negative 1 over x. Then we can find the integrating factor is e raised to integral of px, which is negative 1 over x dx. Okay, this negative can be pulled to the front, e raised to negative, now 1 over x, integral of 1 over x is natural log of absolute x, but x is positive, so we don't need absolute value, just negative natural log of x. And plus c is also not needed, because we are just trying to find the simplest integrating factor. E and natural log are inverses to each other, but there is a negative sign. Negative means negative 1. So we can move this to the exponent. I mean, that's the exponent rule. So e raised to natural log of x raised to negative 1. Now e and natural log, their actions cancel, x raised to negative 1, which is 1 over x. So we got the integrating factor is 1 over x. Now we multiply both sides of star by 1 over x. We multiply both sides. Then this equation star becomes, when we multiply through by the integrating factor, left hand side is automatically the derivative of dependent variable, which is y, times the integrating factor, which is 1 over x. I mean, that's how it works. Okay, equals, multiply right hand side by the integrating factor 1 over x. 1 over x means x cancel, just sine x survives there. Now we integrate both sides with respect to x. Okay, just integrate with respect to x, then we got y times 1 over x. So this is essentially y over x, integral of sine x, that's negative cosine x plus c. So y times 1 over x equals, Now we need to isolate y for the final answer. So we multiply through by 1 over x. So get rid of 1 over x, that means multiply through by x, which is same as divide both sides by the integrating factor. So it's gone. So y equals, we multiply means there are two terms you can distribute. So negative x cosine x plus cx. Final. If an initial value is given, okay, it's not here, then we would just apply that initial value to determine this constant.